welcome to the audience and thanks for coming to this session. This is called A Path to Interoperability. We're going to talk about the independent data layer today and data layers in general. So I'm James Dice, founder and CEO of Nexus Labs. We produce educational content and community events aimed at accelerating the transition to digital and decarbonized buildings. Many people in this audience, I think, or in at least our community, credit me with the term IDL, which we're going to dive into in depth. I don't think it was actually me, but I've been talking about it and enjoy teaching about it for the reasons we'll share in a minute. We're going to talk about the ways buyers of building technologies can buy a data layer. And I'll kick us off by introducing the concept of the IDL. If you're new to it, then these three esteemed guests here will each provide a different perspective based on the work they're doing at Google, QuadReal, and DB Engineering. So we'll go through those four presentations. The four of us will have a discussion. We'll try to say some smart stuff, and then we'll do Q&A at the end. One thing about Nexus Labs events, and this is by proxy Nexus Labs event, we like to have the chat flowing and on fire the whole time. So the team at Smart Buildings Exchange has trusted us enough to turn the chat on, especially for this session. So I want to see a real-time feed of those 60 of you in the audience, your reactions, anecdotes, throw it in the chat. It lets you connect with everybody else. Yes, Rosie, woohoo. It lets you learn from each other while we're talking, and it lets us feel like we're not just talking into the abyss, which is helpful. There's one catch to that. There's no salesy posts. So the reason that this chat is usually off for all of the other events in this conference is because people have lost the trust of the conference organizers over time by trying to push their products and services. So please don't do that, or else they're going to turn it off for us midstream. So please, audience people, put your name and where you're calling in from in the chat. And I'd love it if you also added your experience deploying the data layer. I'd love to see the level of experience we're talking to here. While they're doing that, let's do intros of the panelists. So I want you to say your name, your company, where you're calling in from, and then just for fun, what you had for breakfast. And I'll start with you, Sabine.
All right, hi, I'm Sabine Lam from Google. I am calling from Mountain View in a beautiful phone booth here. And I think a lot of people relate to that. As people go back to the office, we do need conference room, but we're all on conference call with no one around us. So that's my conference room. That's Mountain View. Breakfast, lattes. That's my breakfast. A little bit of milk, some good shot of coffee, and that's where I go. And,
all right.
Good to see you all and excited about this podcast.
Great to have you, Sabine. Thano, you're next.
Hey everyone, my name is Thano Lambrinos. I'm with QuadReal. I run our digital buildings experience and innovation practice. I am located in Toronto, beautiful Toronto, Ontario, in my office that is more and more bustling every day as we start to come back. And I don't eat breakfast. I've started this thing called intermittent fasting, also known as eating disorders for males, I believe. And so I just eat one meal a day, and it's probably a terrible idea, but that's what I do.
Thank you. If I would have guessed that, I would have put that on you. Yes, I would have guessed that for you. That's awesome. Trevor, you're next.
I'm Trevor Sodoroff. I work with DB Engineering, a company out here in Redmond, Washington, and that's where I currently am in my little office over in Redmond. And God, what did I have? I didn't have anything for breakfast. I typically don't eat breakfast. I'm kind of on Thano's train. I usually eat once a day, and ample amounts of coffee and, flavor-free sparkling waters. So
that's not a seltzer. That's not a vodka. That's one of those vodka sodas in a can, is it?
Not yet. We wait until noon to start that.
Okay. All right. So I'd say in summary, we have a very experienced panel, but nobody's eaten yet today, apparently. So we'll hopefully make it to lunch here. All right. So I'm going to kick us off here. I'm going to change this to speaker view for everyone. And oops, I'm going to share my screen. And I'll just provide an intro to the data layer for those of you that aren't familiar. All right, so I've kind of already covered this. I'll go first, then Sabine, then Thano, then Trevor, and then we'll have a discussion. This slide deck, we're going to kind of fly through it. We provide this on our website. It's called Nexus Lore, so anyone can download this deck. Anyone can use these images. You don't have to ask us, just give us credit. So we'll talk about the history of a data layer. We'll talk about the horizontal architecture. We'll kind of walk through each layer quickly, and then we'll set the stage for this discussion, the 3 different types of data layers that we see on the marketplace today. So the IDL story starts with siloed building systems. Each system in the building has its own unique purpose, its own unique inputs and outputs, its own key stakeholders, its own life safety functions. Each of the systems has its own separate stack, networking, asset registers, data models, data storage, user interfaces, different devices. And there's a big gap between what building owners need out of their buildings, which is decarbonization, occupant experience, and what these systems are capable of. And that's kind of where the gap that the smart buildings world hopes to fill. And so practically speaking, smart building solutions need to solve the silo problem by integrating with existing systems in the portfolio, enter overlay software, right? So this is really phase 1 of smart buildings. An overlay kind of sits on top of these existing systems and allows access to data and functionality from those underlying systems. But solving individual problems with separate overlays ends up creating what I call point solution spaghetti. You have a bunch of different applications, hoping to glue them all together in some way. You have a bunch of different user experiences that aren't integrated in any way. And I think building owners are realizing more and more that they don't want to buy all these different redundant point solutions. They don't want to buy redundant layers from different application providers. They want each application they buy to share common infrastructure, meaning walking down from the bottom up, meaning the device layer, the network layer, and the data layer. So that's what I kind of refer to as the infrastructure of a smart building, those 3 layers that kind of provide the platform for applications. So just walking through each layer real quick. So starting at the bottom of the stack, it's not just those traditional silos that I talked about. Modern buildings have all these new devices, right? I heard this in a session yesterday. All these different new connections, all these new batteries, power supplies, dependencies, and owners are left with a lot of complexity that they need to figure out how to manage. Moving up to the network layer, we basically need a dedicated layer that we can manage and make sure that when all this data is being passed across the network, it's done in a secure way. So we can talk about converged networks, having it be monitored, managed, and redundant. Next up is the data layer. That's the focus of our discussion today. Data layer separates the application layer from the device layer. Other people might refer to it as a data lake or middleware. There's a ton of different acronyms for it these days. Whatever you call it, this can be a valuable approach because it provides a standard interface for each application and gives each of those applications a standard interface to each device. So it's upstream and downstream abstraction. And many see this as the first step on the journey to a smart building, basically unlocking the data that's currently locked away in proprietary and/or siloed systems. And I think I mentioned complexity. Complexity is one of the reasons why the intelligence of buildings lags behind more simple objects, like the objects in our pockets and in our homes. Buildings are so complex. There's so many different moving parts. And basically, all of these different moving parts each have different technology stacks, sit on different networks, managed by different vendors, and they're changing each and every day. So any technology that is sort of overlaid on top of that must abstract away. And so a good data layer abstracts away the complexity in 3 different ways. The data model abstraction, third-party API abstraction. So if you have a bunch of different types of sensors, and then finally that device layer abstraction. In order for our applications, which is the next layer in the stack, to do their thing, they're going to need context, right? So the applications need a way to understand all the data they're consuming, including all the underlying devices and how they fit together into that system of systems. And then finally, we're up at the top of the stack. The application layer sits on top and provides outcomes to users through mobile apps, web apps, process-based applications, et cetera. I have someone raising their hand, but I don't exactly know how to call on them. Whoever has their hand raised can put a question in the chat until I see one. It's going to be tough to do anything. Anyway, we'll keep going. That brings us to the point of today's discussion, how to buy the data layer. There are 3 different ways the data layer is in the marketplace today. There's the IDL or independent data layer products provided by a vendor that does just that. And then there are owners that develop and manage their own data layer. And then there are application providers that are providing the data layer as part of their ability to deliver the outcomes of their application. And so I'll walk through those scenarios quickly, and we'll talk about it more later. The IDL is a product that provides the data layer as the primary focus. So the vendor has basically decided we're not going to provide applications. We're just going to focus on only this data layer. And basically what our community tells me and what the vendors in this category tell me is that they're basically selling the ability for the building owner to just do integration once, the ability to avoid duplication in the layers, and the ability for the owner to have choice at the application layer. So if I want to fire a vendor and plug in a new one, I can do that relatively easily is the idea. Second one, Google and Sabine are going to talk about. That's basically a building owner builds their own. And then third, data layer coupled with an application. Basically, we'll talk about that a little as well. Basically, an application provider provides an API also so that any other application provider can build on top of the data layer. As we discussed in a latest podcast episode on the IDL, we call it the IDL debate. There's a lot of this as well, where an application provider just decides that the data layer is no good for them and they go around it. And so finally, we'll discuss throughout the rest of this session, this decision-making process should involve a lot of different factors, and the factors depend on your business cases, what use cases you've defined, the capabilities you need out of the application layer, the human resources you have to support the data layer choice you've selected, and then all of those infrastructure factors that we talked about as we walked through the stack. And then I haven't shared this publicly at all. I just thought I'd share this with this audience. We're working on a marketplace of vetted vendors. So we have these 2 categories that we talked about here today. And we're working on creating standards for each of these categories and actually working with the vendors to vet them. And we'll be releasing that soon at Nexus Labs. All right, so that's the intro. I'll try to figure out why people are raising their hands, and I'll pass it over to you, Sabine.
Boy, you did fly through those slides for sure. I have 3 slides. I will pull them up in a second, and then we'll kind of talk a little slower through it. I'm leading the tech and data team, the workplace tech and data team at Google. But I do want to say everything I'm going to be talking about is very well supported by many other organizations throughout Google, right? So the reason Google can build their own solution is because we're getting support from the network team, from the security team, from an IoT ops team, from an engineering team. And so just wanted to give credit to everyone else that is working on this, digital building platform or building operating system. Really a great collaborative effort. What drove Google to start building their solution is very much we're a big IT company. We know big data, we know cybersecurity, and that's what we care about. And buildings have a lot of information in almost a very scary way. I don't know if you attended Realcomm and the cybersecurity panel there. There's a lot that can be gathered out of this environment. And so really what led this effort to start at Google was cybersecurity focus. And so let me share my screen very quickly to show kind of high level stack and then walk through it, because the independent data layer is one piece of this stack. In our case, we call it the Carson. It's a project Carson, but there's a lot that needs to be figured out to get the data into it. And I think that is actually the very hard part. And then there's more to get data out of it. mainly validating that what you're getting out of it can be, you can apply application to it. So I believe the bottom part of the stack is worth discussing a little bit. In our case, we're trying to find the fastest path from the time the data leaves the device to the time it gets into cloud. And so there's many opportunities out there. There's, the siloed solution where you have a meter, it goes to a, meter system, and then you have your own application, et cetera, and it's kind of a direct path through this energy meter system, and then you have the BMS, et cetera. They're all kind of siloed and all going kind of out of your building into somebody's solution. Potentially you bring it back in. There's like, all of that is a risk to us. We want, if the device is within our building, we want to have full visibility and manageability of this device. As soon as the data leaves the device, it has to be done in a very secure way. So we're looking at different protocols. We're all familiar with BACnet, Modbus, et cetera. By the time the data leaves the device, in our case, we're kind of translating it into an MQTT, more IT-related protocol that is secure, lightweight, kind of allows a lot of data to go through very quickly in a very secure way. So we also make sure that it's on the Google network. So it's a corp managed solution. There's, a lot of question around that. Is it a OT network? Is it an IT network? What kind of network it is? In our case, we do have a network for building automation system kind of technology, and the same capability that we have on our IT network. We want to see what those devices are. Those devices need to be qualified. So Google has put a lot of effort into the cybersecurity and the validation of those devices before they get even installed. Once they're installed, there's a lot of network scanning capability. We want to know what's there and why it's there. And I'm explaining this because not knowing what devices are in your building, or whether they're communicating, or whether they're being hacked or not, will impact what you can do with the data. Of course, it's not eliminating your BMS head-end. You do have a lot of technicians that need to do their work, and we're not replacing a BMS system. We're not replacing an energy management system. If it's installed and you have it, you can certainly use it. But we have a path that takes that data directly from the device to our data layer in a very secure way. Remote access is also done in a very secure way. There's a lot of aspect around that. Well, moving from cybersecurity into kind of the why, once we have figured out this path, this lower part of the stack and make sure it's secure and meeting our requirement, what do we do with the data and how we manage it? This concept of data privacy for Google is super important. Different use cases will have different data needs. Some of them are not PII, but very quickly, if you look beyond your traditional, reporting on CFE 24/7, you have just metering data. Okay, that's not security-wise or data privacy-wise is not too I don't know, complex of a problem or too scary of a problem. The data can be lost in some way, not lost, but at least if it's hacked, it's not the end of the world. But there's a lot of other sets of information that carry PII information as soon as you can combine it with other things. And we're very wary of sharing our data outside of our environment. And I'm saying outside of our environment because it doesn't mean we can't use third-party application, but it does mean we want to keep it within our environment. So data does not leave our building. It's just a requirement in our company. We also like to augment it, right? We like to augment this information from each device with potentially spatial awareness. We have meter, energy consumption. Where is it? How and where is it? Not the meters itself, but for, FCUs, any other devices within the building. What is their location? What is their relationship with other devices is an aspect that we manage within the IDL. The data is normalized, obviously, and then we want to be vendor agnostic. So getting the data directly from the device to cloud allows us to keep it vendor agnostic, allows us to normalize it in a way that is kind of hiding all that complexity from API to API kind of approach. because each vendor is going to have its own ways of normalizing the data. And when they send it over, it's going to look different from one vendor to the other. We very much care about systems integration. When Google has a whole lot of tools within our landscape around how do you report problems. We have guts tickets. We have each vendor owns their own CMMS platform. And so the integration with those internal tools that allow the operation of the building is quite important. And we feel that adding a third party or going with an IDL from that third party and then integrating this with internal tool is a huge amount of effort that makes owning that part very valuable. Also, we kind of believe that API to API integration leads to a lot of maintenance. It's just API maintenance at this point. Things change all the time, and we'd rather work on that data layer itself and enabling a lot of different capabilities and a lot of interoperability between systems within that data layer. We have other existing tools. We have a whole GVC system here. I'm not using it in this case because it's Microsoft, but we have GVC, Google solution, audio video system that we know how to manage. We have physical security camera that we know how to manage securely. We can similarly manage IoT devices, right? We can use our asset management solution, augment them to expand it from one world to another world. We have alarm management for physical security camera. We can augment that to then start supporting IoT solutions. So, again, an internal solution allows us to leverage existing tools in ways that we couldn't do by using a third-party solution. So that's kind of in summary, the why we started with this solution. And there's many protocol and open source and a lot of other things that kind of build this building operating system solution. But other drivers behind our choice is that, I feel like what we see as current solution just don't work at scale, right? If we wouldn't be having that conversation if what existed today worked. There's always every large real estate owner is going to have one very smart building, but somehow one very smart building showcase the edge. I know JCI has one. Everybody has one building, but can't reproduce it because this integrating kind of siloed system is just a very costly, time-consuming effort that requires ongoing maintenance and support. So feeling that if we can centralize it for us, it will be very helpful. And then, at the end of the day, we're kind of looking long-term. There's this concept of right now, almost baseline data is important. We just need to know what's going on in our building, and then we want to optimize it. But really, the long-term is to take it to a level of automation that is not seen currently in the industry, right? The level of automation and optimization using ML and AI that is not seen in the industry. And I don't think we believe at Google that we have a lot of knowledge in that area, and we should leverage that knowledge for the building, smart building world. I have plenty more to say, but I want to make sure we take turn. And I can, I know there's a concept of how we approach it. I start touching up on, do we build everything ourselves? And the reality is we kind of mix and match, right? There are things that we build ourselves. There are things that are open source. There are things that are third party, but we bring in internally. So we corp host those third party solutions. It's almost like a black box that is within our stack and that we manage internally. And that black box is usually customized for Google. So it becomes like more of a 2P than a 3P. And it's really just building blocks of little system that leads to this entire OS there. James, I'm sending it back to you unless you would like me to continue. I think I can come back to other slides afterwards.
Yeah, well, thank you, Sabine. While Thano's getting his slide deck up, if you could stop sharing, and then I have a question for you. Can you talked about API to API integration as a headache. I don't know if that's exactly what you said, but it was something like that. Can you talk about like what's the alternative? Just describe what you guys do instead of the API to API integration. You're muted, sorry.
API to API means you have your device sends data to a headend or a VMS somewhere, and then you send it back in via an API. Centralize it because you want interoperability between systems, right? So you have a BMS, you have EMS, you have lighting control system, you have a lot of different things via API. So right now for one building, you have 5 APIs into one centralized location. And then you have another API for an application potentially to run on top of it. First of all, those APIs are going to be different for each building because each building has a different lighting control system or energy management system. And so you have to repeat that integration individually per building because for each vendor that is installed in your building. We're ignoring that part. We're taking the data, the raw data directly from the device to cloud. So we're taking your backnet raw data, and that's what we're kind of anti-proprietary solution is from the device to cloud. And so it sends the information directly. We're not leaving the building. We're not going through a third-party app back into an internal IDL.
Got it. Thank you. All right, Thano, take it away.
Hey everyone, first of all, thanks for inviting me. Excited for this conversation. As dorky as it is, it's a super important one, and it really is the enabler for a lot of the things that we want to do in the real estate space and how we intend to move it forward. This is a critical piece. So I just want to give everybody a sense of QuadReal. As mentioned, my name is Thano Lambrinos. I'm responsible for our digital buildings practice. So we look after everything from infrastructure within the buildings. I'll talk a bit about that, M&E and connectivity, the connectivity being one of the specific and key foundational pieces, the way that the buildings connect, the way that the people connect to the buildings, the way that the systems connect within the buildings, kind of like the marshmallow and the s'more that sticks everything together, that connectivity piece. The systems themselves, the integration of those systems through, as James articulated, one of the options of the data layer with applications associated to it, and I'll talk a little bit about that, as well as customer technology and how we interact with our customers in the built environment and how they interact with their spaces. So we really have kind of an end-to-end type of approach and team built out so that we can manage, on outcomes, whether they be operational or customer facing. So I put this slide up to give you a sense of who QuadReal is and what we look like as a firm. As you can see, a significant number of assets under management, almost $72 billion, spread out over quite the range of asset classes, both here where I am in Canada and internationally in the US, in the UK and Australia and other areas in the world, and 1,200 employees. So you can imagine that deploying a digital strategy at a firm of this scale isn't easy. So there were a number of things that we had to put in place to support this idea of a data layer, but I'll talk a little bit about our evolution and how we kind of got to where we are today. So I've been here now for just over 5 years. And in the first couple of years, we really focused on creating standardization, which I'll talk about. A data layer is absolutely useless unless you have the infrastructure and the resourcing in place to appropriately build and retrofit buildings and systems such that they can easily integrate into a data layer that can enable all of the outcomes that you're looking for. So in order to do that, you really have to focus on the construction and retrofit methodology and the specifications and the way things are written. And I'm sure Trevor will talk about this being from an engineering firm, and that being a critical piece to enabling what is to come and how those systems ultimately connect into the layer that we're talking about. So we spent a lot of time in 2019 through 2020 focused on connectivity. Again, the deployment of connectivity. If you can't connect to the systems and you can't get data flowing and moving out into a centralized environment, then again, the data layer is effectively useless. And then through 21 and 22, started deploying what we call, James is taking credit for IDL, I'm taking credit for IBMP, because IBMS sounded too much like BMS, so I put a different letter at the end, which was what we call our integrated building management platform, which includes elements of the data layer. And I'll talk about how, you know, the data layer can be broken up into a couple different pieces too, as it is meant to support building operations, but also the enterprise and how those things link together. So we spent a lot of time on the selection of that, the deployment of that, as well as our customer experience apps and other digital platforms that we were deploying. Through 2022, I like to call, as you can see, I have different names for each of the phases of this evolution: identifying, pilot and testing, failing and scaling, where we did fail on a number of things that we put out there, but thankfully our architecture and approach made it such that we were able to remove things relatively easily and replace them, but really focused on the sunset of those failures and the aggressive deployment of connectivity, the tenant platforms, and the integrated building management platform. And as we move through 2023 and beyond, it's really about optimizing and enhancing. And as I mentioned, expanding the group's focus to focus on all infrastructure in the built environment and making it real. So our strategy through 23 was called Save Money, Make Money. So unless we were saving money or making money, we weren't doing anything. It didn't matter what the solution and opportunity was, unless we could find a way that it would materially save money for the organization or create a revenue stream, which we were able to achieve both of those things with a number of the initiatives that we had. We weren't doing it. So I'll talk just expand on a couple of the things that we did over the years and kind of the foundational pieces that enable our strategy to have been as successful as it's been to date. One is the digital building playbooks that we've deployed. Standardization and repeatability is absolutely critical for the same reason that a data layer exists, so that you can have scalability across the portfolio. You need standardization and documentation and specifications written so that you can buy, build, retrofit buildings appropriately so that they can leverage that infrastructure. So our playbooks do focus on the strategy, system design, specifications, the way that we procure, how we deliver responsibility matrices, things of that nature, commissioning, and then handover into operations and how we engage with the customers. And through that, we are developing our own actual construction divisional specifications because we feel that we get a lot of variety from the consultants, and we want to make sure that we work with the consultants, but on paper that that we kind of originally shaped. So when we look at the areas that we focused on, it started with connectivity and operational and customer technology. We very quickly realized this group needed to be responsible for the deployment and specification of all systems, building automation, lighting controls, everything that James had on those slides, including IoT, including parking, and a number of ancillary systems. So we're responsible basically for everything in the building with the exception of the concrete and the glass, and have recently expanded into M&E with the thesis being in order to realize operational and customer outcomes, and in order to implement that data layer effectively, as mentioned, the systems need to be designed and specified and deployed appropriately and connected appropriately. And you can't do this. You can't do the customer and operational outcomes without appropriate system design. You can't do appropriate system design without appropriate infrastructure design. So now we look at it across the platform. And I don't have the slide in here, but have realized literally millions and millions of dollars in savings on one specific project case study. Getting involved in M&E with our specialties that we've hired and brought in-house just through better design, better approach, better integration across the stack, save that project, and we continue to save it. We're up to $25 million in deferred or avoided costs or design augmentation that would have gone in a different direction if we weren't involved. And then underneath, you can see that's why we're involved all the way through from design through to maintenance. So some of the things that are really going well, James brought up the idea of converged networks, and we've deployed at scale. We've got over 40 buildings, actually closer to 50 buildings, if not more now, that I think about it, and it's expanding to our residential platform as well on our passive optical networks, and I'm happy to expand on that. If you're using anything other than passive optical, I would really encourage you not to. Much less expensive, much easier to scale and deploy and manage with the appropriate cyber protection in place. And now we're starting to utilize that infrastructure both in office and in residential environments as revenue generation, where we look at providing connectivity services to the various different tenant types that are adding, for example, in res, up to $30 to $50 a month per unit in new revenue, which we're pretty excited about. So here's the data layer piece with applications deployed, our integrated building management platform. We work with a company called Code Labs. And as mentioned, for us, and I'm sure there'll be a bunch of questions on this, it was really critical that the data layer be able to also show some value. So we found it much more conducive in a real estate environment that is very asset management and investment driven to be able to show outcomes almost immediately by the deployment of this infrastructure. So as you can see, we've deployed over 50 buildings, 250,000 devices, 30 integrations, over 4 million data points. And we're doing things like optimized start, stop, and functional testing, as you can see on the left, where we've saved 70 in the 6-month pilot we ran, and we're now expanding it across the portfolio, saved over 75,000 hours in runtime on these fan coil units, managed while doing that to continue to ensure that the tenants were comfortable and the experience was at the highest it could be, and deferred quite a significant amount of capital, not to mention energy savings and other elements that or other value streams that came out of doing this. So, for us, this area, there's a big focus on the built environment. There's a big focus on having applications be able to leverage this data layer that are part and parcel and native to the data layer with applications itself with code, but also outside of that and integrating directly. And then one thing I can expand on a bit later, if you'd like, is how we're tying that in and how we're working with our enterprise folks that are creating their enterprise data platform that will dovetail into this. Now the data sets are different. The frequency of how machine generated data is obviously much heavier than human generated data, and how we're looking at all of those things differently to realize our outcomes. But that gives you a sense of what, a very high level sense of what we're doing, and then working towards this building BI tool and stepping the level up, taking it more than just building analytics and building optimization and building command and control and fault detection and things of that nature, but reporting it up to a senior level to get better insights, higher level insights, and support bigger decisions across the portfolio based on historical information to support capital decisions on equipment that we're purchasing based on information we have across the portfolio, things of that nature. This is, one of the apps that we plug in, which is our QuadReal Plus Home app, which we're really excited about. We've just launched it this year. We had our own apps in the office space for a while. We've recently launched our own residential platform and have had a significant uptake of it. And it's the data that's coming out of that, while admittedly we haven't figured out what exactly we're going to do with it, is going to certainly allow us to have a significant competitive advantage and better understand our residents as we expand the residential platform, which is happening in a big way. And the same thing with workplace, obviously not as big a conviction on the office side, but we're certainly spending a lot of time doing what we can to differentiate our assets in our office space from our competitive set. And one of the ways we do that is by integrating a lot of the building systems, IoT sensors into this platform that we've developed that also has desk booking and amenity booking and all of the other features that you'd want in a workplace platform, but coupled with environmental control and coupled with IEQ and coupled with occupancy and things of that nature that we are offering to our tenants as a value add as well. And just some examples of how we're creating value in office, both at 745 Thurlow, which is a retrofit, where we're seeing significant savings in a number of areas, some that were didn't even really pro forma out because we weren't sure what they'd look like. The ultimate goal is to leverage the data, leverage the information to get rid of service contracts, to work completely towards proactive maintenance and only deal with certain vendors on T&M. On the right, you'll see how it was deployed at River South, which, if you've heard me speak before, I speak about it quite a bit as ground up construction and probably one of the most advanced buildings in the US today. And then on the residential side, very similarly, the apps, the platform, the network, creating kind of the three legs to the stool, so to speak, the infrastructure being leveraged to generate additional revenue, and also enhance the experience with various different sensors that feed back into those applications through that data layer. So I'll stop there. James, hand it back to you if you have any questions, or we can move on.
Thank you, Thano. While Trevor's getting ready, just a quick question. I think it'd be good if you kind of explained, did you guys look at independent data layers when you sort of went out to the marketplace? I know you guys did a thorough search when you guys searched and selected Code Labs. And maybe just explain what you meant by, you needed an application that provided value very quickly.
Yeah. So when we looked at the market, so I'll answer the last question first. When you're dealing in a real estate organization that has operated very traditionally for a very long time, and asset management and investment folks that are used to spending money on something that generates some sort of feasible return almost immediately, or at least has a path to it in the very, very near future, it's tough to pitch the idea of just a data layer that's going to aggregate without really understanding what you're going to layer on top that will deliver value, right? And then also having to buy multiple platforms to satisfy some of these use cases. So it was an easier approach for us to look at the data layer with applications that also had the capability to be that data layer and allow integrations, easy integrations, API integrations with various other sensor vendors, with various other solutions to get that data in and out very freely. Now, again, on top of that, as I mentioned, we are our head of data and analytics on the enterprise side that I work very closely with is creating a corporate integrated or enterprise data platform, EDP, that will tie into our infrastructure as well. So it'll be a sum of some parts that'll ultimately make up our stack, but it's continually evolving. So that's really why we went through the process that we did. And to answer the first question, it was really focused on those data layers that had application capabilities bolted onto them as well.
Awesome. Okay, thank you. And over to you, Trevor.
Can you hear me? Perfect. My name's Trevor. I work for a consulting engineering firm out of Redmond called DB Engineering. And so my perspective is not one of a building owner, but really as an implementer of things that building owners want. And I've been fortunate enough over the last 10, 11 years to be able to see dozens of different deployments of dozens of different styles of things that you might consider IDLs or evolutions towards an IDL. And so what I thought would be interesting for me to talk through with this group would be kind of what I've seen as I've looked around the industry and been involved in, Google's deployment and Microsoft's deployment back in the day, but other customers that haven't been so public with their information. And so I'd like to discuss some use cases a little bit, discuss some of what I've seen, and just do some cross comparisons for people that are out there maybe looking to potentially build it themselves, or they're going to go to the market and they're going to find a product that does it. What sort of things should they be on the lookout for? What things are, in my opinion, integral pieces that need to be handled? And so, again, I mentioned that we're a mechanical engineering firm. We specialize in smart building tech, and really we are application users. We love the data. We use it to optimize buildings, improve facilities operations, stuff like that. And so we always end up getting into that data layer, and it just becomes part of what we have to deal with if we want to do things at scale for some of our bigger clients. Our clients span many different sectors. So like I've seen it in corporate real estate, commercial real estate, high tech, retail, data center sort of spaces. Like I've seen a myriad of things. And so I thought it would be interesting to just talk through maybe the evolution of this and some of like the key sticking points here and what you ought to be looking for. So, well, I guess one other thing I should probably mention is that we as a company believe very much in open technology, not just like open source technology, but like interoperability between technologies. I do not want to be locked into a box. As soon as you give me an application, I'm going to think of something else to do with that data that the application can't do. And I can't wait for an iteration for it to be, developed and baked into the application and rolled out. So I have to be able to do what I want to do. That's how we as a company drive value. That's how others in the FM facility space want to be able to interact with something. They want the application, but they want to have some freedom in there as well. And also, I'm not afraid of DIY. And so this idea of building it versus buying it is very compelling to me because given your use cases and what you need to do, it can actually be better for you just to build it yourself than to go out and buy something because it gives you much more control. And so let's just start by talking about the legacy setup. James had mentioned something similar to this, although it was a little bit prettier. This is how kind of the typical application is set up. And you've got one application that's, say, doing FDD. It's going to have some integration into the network devices. It's going to do some modeling of them. I use the term knowledge graph here because I just hate the term digital twin, but like it's literally just a database that represents the connections and representations of devices. You have a pipeline, you'll have some data that's stored somewhere, historical data, that sort of thing. And you'll have some application that uses it. And so, back 10 years ago when I was working at Microsoft doing this, they did a big open study that they, shared with the world. And it was really cool for the time. But the thing is that they were very much locked into the one application that they were using. And it was hard to get data out and start to do interesting things with it that the application didn't support. And so before the days of, REST API as a kind of the standard, you were sort of stuck. And that's kind of where as we start to move into this scheme, it's becoming much more interesting. And we have to make some considerations around what things have access to this data and what this API even looks like. But if we just back up for 1 second and talk about what the data layer represents today, it's essentially the same thing, but with the key piece being this API and the independence of that application from the data itself. Really, really important. I think that it makes the most sense in the world to have that independent data layer there so that you can swap out applications essentially, because maybe one application is better for this thing, maybe one application is better for this other thing, or maybe this one application is the one that you've used historically, but you find one that does it better. Well, you don't want to lose the data, you don't want to be vendor locked. So having this independent data layer, especially one that you manage, can be very compelling, but it's a dangerous thing. And so I want to talk quickly about the pros and cons from my perspective and what I've seen with having what you might consider the application as the data layer, or like an application that you stand up that happens to give you a data layer experience on it by virtue of it being deployed. The purchased IDL, which is, like a middleman sort of product for the data that does a good job of representing it, but doesn't do much more beyond making that data available. And then similar to like what Google is doing, this self-built IDL. And really the application as the data lake is tricky because obviously if you pick a good application, you'll get that good use case solved. But depending on how it is set up, you might not have the ability to pull that data out and easily make it available to other applications. Now, this is becoming less and less of a problem in recent years as more of this interoperability becomes necessary and kind of like forced by the market. But it still can be a challenge if you want to take an FDD platform and you want to make it do something else. If that application doesn't have an API and it doesn't represent the data properly on the back end, then you can run into some trouble. It's that data representation piece is kind of a real critical, and we'll talk about that here in a minute. But in general, like an application as the data layer is usually good when you have kind of like limited use cases that you want to be able to support, and you're kind of more concerned with just getting something out. You obviously have very little control over the architecture or over what the thing is developed on because you're just buying an off-the-shelf product. And the same is true really for the purchased IDL as well. Like you have minimal control over how it's actually set up. Maybe you have some options. It's hosted in Google versus it's hosted in Azure, that sort of thing. Maybe it's hosted on this virtual machine, but like other than that, the implementation details, you're kind of paying not to see those. So you have to be happy with that. And some customers are good with that, and some customers are not so good with that. But obviously, the purchased IDL, in my opinion, is much better than the application as the data layer, because at least with the application independence, you can swap out different components. But like if you don't like a particular vendor's FDD, but you want to retain them as the data layer, it can be a little bit of a challenge just to, you know, peel them out from something that they were doing for a long period of time and just to retain them on the data layer side. And in fact, that is something that I've seen happen with customers in the past, where that application just goes away and they don't want to use it for that anymore. And now they're paying application money for what is essentially data collection. So purchased IDL, a lot of good reasons to have it. But then there's this concept, very intriguing, very enticing, self-built IDLs. And I've seen customers do this that are obviously as sophisticated as Google, but also not as sophisticated as Google. And they've had both success and failures with it for some reasons that we'll talk about. But really the compelling thing behind an IDL is you have maximum control. If you build it yourself, you know what everything is, you know how it's set up, and you have total, cybersecurity control, you have total backend control, you can represent the data any way that you like, you can make up new ways to represent the data if you like. Very compelling from like an engineering standpoint, because I can basically make it do anything that I want. However, you have to be capable of making it do that. And that's really the challenging part, right? Like, who are your technical resources that would be doing this for you? The good thing about purchasing an IDL from the open market is that, like, the proof's in the pudding. You just look at the application, you can see how it works, you can functionally test it against data, and you know it works. Whereas if you're going to build it yourself, there's something to be proven when you go to set it up. And then of course it requires ongoing maintenance. This is super directional. Take this with a big old grain of salt, because I know that people are going to be arguing in the comments about what this means, but I just wanted to get this idea out here of like what it is that like directionally is going to push you towards building it yourself or buying it. And really that thing is control. From what I've seen in my experience, that thing is control. We want control over who owns our data, where our data sits, how our data gets into our platform, the ingress, the egress of the system, who has access to our data, right? Like the more that you want strict control over that, the more it's going to force you into your own managed infrastructure and really into your own managed software. And so that's why over here you can see it kind of like cruising off as you require more control. Like you're really getting to the point where you might want to build it, stand it up yourself. And then of course the variety and quantity of use cases, I think also makes a compelling reason to have an independent data layer versus just an application that does it. For some customers out there that I've worked with, this application level is perfectly fine for what they do because they don't have ambitions to do much more beyond it. But as soon as you start getting into like the Google use case, where it's like we have hundreds of things that we want to do with this data, and they're all distinct and different, and you're not going to find an application that does all of those things together. You need that independent data layer. Whether or not you purchase it or build it yourself is then kind of dictated by that control piece. So again, very directional, but this is kind of, if you're in the position where it's like, well, should we build it? Should we not build it? Maybe we should talk about some of the gotchas. Oftentimes, and James said this earlier, these things are built around use case. That is, the applications are built around use case. And the IDL suffers from probably one big real challenge technically, in that it is difficult to foresee use cases, and it's difficult to build data models, machine readable data models for use cases that you haven't foreseen. So it has to be a somewhat flexible data model, but it also has to be, somewhat, you have to be able to somewhat foresee your use cases. Either you have them very concretely defined, or you have like these kind of more ethereal ones in the future that you're going to go after. You do need to have some idea of use case. Do not say that you're going to implement an IDL and then you'll figure out what to do with the data later. No. Use case dictates modeling, and it dictates how you set up the platform. It dictates what data you bring in. Use case is everything. Don't forget it. Communication and network pathways are also really important. You have to have that figured out. Luckily, most IT groups will have that kind of like buttoned up for you. You'll know what you can and can't do, and it's just a matter of like, squeezing through whatever the requirements are. Drivers and protocols are actually really important, because you wouldn't think that like in an IDL it makes sense to or that it matters, because on the other end, you're going to get an abstraction. But if you're setting it up yourself, you really do need to pay attention to this. I've worked with customers that have implemented their own drivers and their own protocols, and they weren't very careful with how they were setting them up. And so each driver had different representations for different types of data even. So they'd have one manufacturer that gave them sensor data, or they had one manufacturer that gave them, I don't know, configuration data. And you'd end up with different payloads from different controllers, and they would represent themselves differently. And it was just a big pain to unjumble that when you served it up to the user, which is really a problem because you want that data to be easily discernible. That the whole point of the IDL is to centralize and abstract that networking level stuff. So don't forget that. Like if you're setting this up from yourself, you really need to consider this. Message standards is also part of that. Like, you know, the driver is going to be giving you messages of a particular type. Google specifies one themselves called UDMI. There's another one called MQTT Sparkplug B, I think, which is another alternative to that. But like, pick a standard and stick with the standard. Don't have no standard, because then you'll be dealing with, you know, code spaghetti. Modeling is also really, really important, and you need to pick a model that makes the most sense for you. Google has their own standard, which James, I think we talked about on the podcast before. But there's also Haystack, there's Brick. There are a bunch of good standards out there that you can use, and you just need the one that's built for, again, the use cases that you have. So if you need stricter configurability, or if you need stricter enforcement, then you need a stricter standard. And if you want it to be a little bit looser, but you want the application layer to be able to do more interpretation on its own, like it's going to have to sift the data a little bit more, it's not going to come out perfect or perfectly described for its use case, then go the looser one. But you need to have an idea of what pros and cons are for the data model that you're using. Don't forget. Access points. This is actually probably another really critical one, because we always talk about APIs, but an API can be almost anything, right? Like APIs can be REST APIs, which I think is what most of us think about when we think of APIs, like HTTP calls to a web server, and it gives us a response, 202, 404, here's a JSON message. But there are other types of APIs too. You can interface directly with a database, a remote database, and that can often be a better solution for you, because if your end users are analysts rather than an application, that's actually probably the better way to go. And in fact, we've run into trouble with that with certain clients, where like we've built one interface, but what the users really needed was another type of interface. And so understanding your users is also really important. And those are just technical considerations. You also have organizational considerations. Like if you're building it yourself, do you know how to do this? You really have to ask yourself that, because, you know, if you don't know and you don't think that you can do it, or you can't find someone that can help you through that, you really probably shouldn't build it yourself. Google obviously is Google, so they can build whatever they want. But like others that I've worked with in the past have struggled with that. Yeah, obviously, like this is probably a non-starter. Don't even need to mention it. But you know, if you're an Azure shop, you know, don't go buying an application or an independent data layer that's built on Google, or vice versa, right? You need to set also your ownership philosophy. Data ownership is really going to be a key thing for you. Who owns it? How do I get it? What if I can them and I go with another provider? How do I port that data over? The data is the resource that you care about. So how much control do you want over it? How much ownership do you want? And of course, you have to understand your expected outcomes, right? Like what, similar to the use cases, but like really not just like, oh, I'm a user, I want to be able to do this, but like, what do I expect to gain from it? And am I getting my ROI based on that? You need to set those kind of in advance and be realistic with those expectations. And probably the one that goes most, I guess, ignored at their peril is data maintenance. Some of my clients have hundreds or thousands of sites, and data maintenance at scale can be an absolute nightmare. So you really need to understand the standards of your organization, like Thano had mentioned, right? Like this is a big part of the first bit of what he had to do. Every organization needs to do this. So if you don't have good standards, you're going to step into a world of pain, not maybe during initial deployment, because you'll, you know, just struggle through it, but subsequent maintenance and believability of the data will just erode. And that's when you lose users, and that's when you lose everything. And then of course, with the intake process here, you need to have some way of knowing that like, hey, we need new application requirements, or we need new data requirements, because while you might have a backnet controller that can give you 1,000 data points, typically during an integration, you're going to pare it down to some reasonable amount based on the use cases that you have. And of course, it's not going to be perfect for the use case that you come up with 5 years from now. So having some process for managing that change is really important. I think that's kind of all I had to talk about. Hopefully something in there was useful to someone that's looking at going down this path. But yeah, looking forward to getting the discussion, James.
Me too. Thank you, Trevor. All right, let me make sure that everybody can see all of us. All right. We have some good questions in the chat.
Did you kick my screen off? Is that why I can't stop sharing it?
Somebody did.
Okay, perfect.
Yeah, it wasn't me. We got good questions in the chat. I'm sorry, in the Q&A. If anybody has any more questions, please put them in the Q&A and not the chat. It's good to have one place to look if you're sitting in my seat. Okay, we have a bunch of categories of questions that we might take this. We could take this in a bunch of different directions. I'm thinking practical is the best, rather than sort of future looking and sort of thought leadery. So let's at least start this discussion with how to actually do something, as Thano likes to say. It's one of my favorite Thanoisms. Let's actually do something. So can you each maybe just start us off with, if I'm a building owner or anyone in the ecosystem, I like to send this message to application providers and service providers. How can everyone sort of get on the same page with this idea, and what is the sort of first step if you're sitting here in the audience? Somebody go first.
So yeah, sure. First step, as mentioned, is identify, and I say this over and over again, so for those who have listened to me ramble about it before, you can, I don't know, find something else to do for a couple of minutes. But like, the reality is you need to identify what outcomes you're looking to realize are, and you need to create that standardization at the firm. If you're a building owner manager, as to how you intend or what use cases you intend to stand up, and then how you intend to create the foundational elements within your buildings, whether you're building them new or you're retrofitting them to enable the flow of data into whatever infrastructure or architecture you so choose to do it in, so that you can see the use cases on the other end. And I mean, that's kind of step one. And then
can I pause you real quick? Can we just stress that point? What happens if I don't have my use cases defined and then I go out and deploy a data layer?
You're going to waste a bunch of money, or you may not waste money, but you'll spend a bunch of money and you'll stand something up that you'll have nothing to do with. It's what's a bad analogy I can use? It's like buying the fastest Formula One car and then getting in it without having a clue how to drive it. You're just going to be in there pressing buttons, and then you'll probably drive it into a wall and kill yourself. Like, that's might be a bit extreme, but that's kind of really what you end up doing. Is there's a lot of sophistication in some of these tools that you're buying, and if you don't know how to use them, what's the point? And you don't have an outcome on what you want to do on the other end, what's the point? So yeah, no, it's a critical piece, and if you don't do it properly, the whole strategy falls apart. And then you don't have a strategy to articulate to your management, which means no one's going to give you money anyway. So that's why it's really important to take a measured and stepped and pragmatic approach to doing any of this stuff.
Trevor, you kind of smirked there. You got something to add?
He's so right. We have to talk about that very concretely. So, for example, when we were standing this up for one of my clients, one of the things that we explicitly avoided integrating with were alarms, because what was our use case? It's energy savings. It's, FDD, that sort of thing, right? And then it turns out that one of the biggest challenges that they really had, the thing that would prevent them from doing anything with FDD, was the fact that their alarm management was chaotic. They couldn't do it, right? They had so many that they couldn't manage them. And so because our use cases weren't well defined, our integrations missed some critical data that would have been very beneficial. So you have to have your use cases figured out. You have to know your outcomes. You have to pull the audience, right? Like, it's easy enough for us to sit in ivory towers at the C-suite level and say, hey, we want to drive energy savings and blah, blah, blah. Go talk to the FM guys. Go talk to the operators, the techs, because they're the ones that are actually going to do something with your data. Make sure that their use cases are accounted for too. Win hearts and minds.
And I think this is just like, we can go back to my slides if we want to, but use cases define the capabilities that your application layer needs to have, which then defines what data you need. which then defines what the data layer needs to have in it, right,
Yeah.
to enable the applications. And so if there's only one takeaway from the day, let's not even talk about the data layer until we have our use cases and outcomes defined.
But then again, don't let the pendulum swing too far the other way, though, right? Like, don't be so rigid in your use cases. It's like, if it doesn't do this, then we can't integrate with it, right? Like, you're gonna have to have some fluidity there. You know, have some anticipation. Have a data layer that is malleable, that you can, you know, adjust the modeling on. Don't be afraid of refactoring a model. It's software. It's bits on a drive, right? It's ones and zeros. So don't be afraid of that sort of thing. Be good enough for what you're trying to do. Don't be perfect. That's what kills a lot of these deployments.
Totally.
James, I wanted to follow
Yeah,
up
go ahead,
on
Sabine.
a segue that Trevor mentioned, data maintenance, because you have your use case. Even before you go down the stack, I think it's important to realize the status of your building, right? A use case as simple as reporting on your carbon-free energy 24/7, which just need metering data. You would think the simplest use case possible. You even have meters in your building, right? So you have a use case.
Yeah.
The data is available for one thing, and then what is the quality of that data? Because the reality is, it's a recent thing for this industry to rely on the data as much as we're trying to rely on the data today, and the quality of the data is a complete disaster. And so I understand the concept you're bringing up as saying, you know, use case and then the IDL and then you go down the stack. But the reality is the huge issue once you define your use case is actually understanding the quality of your infrastructure within the building and the quality of the data you're getting for it, and how you're going to address that before you can even present your use case. So
Absolutely.
I think that was a huge learning for us and a huge, I think, industry.
It's
concern.
almost like a top-down and a bottom-up approach that needs to happen. So yeah, the last project I worked on an IDL, they had 210 meters. That's a perfect example of what you just said. They had 210 meters, and they're sitting there at the application layer wanting to do reporting for ESG purposes, and no one knew of those 210 meters any sort of hierarchical relationship information, which one's the main meter in the building, which one's downstream of that, which one's for the 60th floor, which one's for the chilled water plant. Like, nobody had any idea, even though it's a brand new building, what all those meters were.
Are they even reporting accurately, right?
Yeah,
Are they even
exactly.
reporting accurately? Is the data complete? All that is actually.
So let's talk about that device layer as sort of a second step here in getting started, sort of preparing your devices, preparing your data for the IDL or the data layer. Thano, you mentioned having these design specifications spun up. Can you talk about how, like, why is that so important for enabling whatever data layer path you choose?
Yeah, so again, as part of the standardization in the playbooks that we deploy on on any new construction or on any retrofit project, there's a number of requirements in there. Everything from what the nomenclature needs to be, and to Trevor's point earlier about haystack and brick and all these different standards. We actually created our own, where we smashed a bunch of them together because there was nothing that really satisfied everything that we needed to address across the board. Side note, I'm considering making that open source just so that I'm not the only person using that structure that we created. But at any rate, so for everything from that to the way that the vendors can connect to a network infrastructure, ensuring that they can absolutely do that, to enable that data flow, to the way that they communicate, ideally APIs, but in some cases BACnet, in some cases, in the cases of metering, sometimes Modbus still, and ensuring that all of that is open and easily architected and set up so that we can then plug those devices into the platforms, the data platforms and the application layers that we need to ultimately report on. And then, of course, not only that, but having tools that take to your point, the physical documentation, so that we can reference data points with where they exist physically in a space, what the feeds to fed from relationships are between devices, which is something that is obviously typically very difficult to nail down, even in brand new buildings, that allows you to then effectively not only report, but do kind of daily appropriate command and control, do daily appropriate analytics and insights. So there's a lot that goes into it to make sure that those devices are appropriately designed, deployed, commissioned, and then maintained. And you need to figure that out from the beginning. And if you don't, what's the point of any of this, right? You may as well just throw it all in and hope for the best, which frankly, a lot of people still do. So.
Totally. And Sabine, this is something that you guys work on heavily as well. Do you want to share how you guys think about that device layer enablement?
Yeah, so similarly, we have a lot of standards and processes and how to deploy things. The reality is it's a human doing the work, and it's a human implementing or following those guidelines. And at the end of the day, any process that involves a human is unfortunately likely to fail at some point, or so I think the concept of validation throughout the pipeline at every level of the stack in a way that's automated or at least software driven is a key element of the solution. And so I think Thano mentioned he has his own tagging approach, just like we do. You're not using haystack, you're not using break. Like we all feel like there's a need to do something specific because what's available doesn't cover all angles. In our case, we created the digital building ontology, and one of the concept was that it had to be very prescriptive, so we can validate how we model the building. So this digital representation of the building needs to be accurate and predictive, right, and predictable, and we can compare one building to another. We felt that haystack was a little too vague, and you have plenty of ways to represent the same thing, and that prevents you from validating your model and then ensuring that what you have in your data layer is actually accurate. So there's a lot of reasons why we built certain things. I know there was a question as well, is like, can't we just standardize and everybody does the same? It might be that we're not yet mature enough and have gone far enough to be standardized. Things are open source, we're all trying out new things, but I think my point around all this is the validation at every level of the stack. And I think we have 8 different point of failure before you can ensure that the data that you start using at your application layer is actually representative of what it should be, and you can actually make decision and act on it in a way that's accurate, as opposed to doing the opposite of what you should do because it's inaccurate. So there's a lot I think Google understands as a big IT company. We know the 4 nines or 99.9% accuracy, and that is not something that applies to this industry yet. But what's the goal? Can we be okay with 95%? Can we be okay with 80? What percentage is enough?
All right, thank you, Sabine. We got 16 minutes left, and we have 8 questions from the audience that are open. I'm wondering if we could do like a rapid fire. So we're not going to get everybody's take on everyone. We'll just I'll say the question, we'll raise our hand. That person's got 2 minutes to answer, and then we'll get through all these. Sound good?
Send it.
Okay, I think there's a question around, this is a sort of getting started with IDL sort of question from Gabe around the difference between a front end, and I think he's talking about a building automation system that's sort of on-premise. What's the difference between that and an independent data layer? Anybody want to take that? Go ahead, Sabine.
I can take that one. I mean, one is a front end for one system, and the IDL is a front end for many systems. And actually, it does not include the application and not necessarily the front end, but at least you have multiple systems within one data layer. That would be my thing. So siloed versus integrated.
I think one thing, just to add, one thing that's important to think about, one of the things that we actually do is we still don't eliminate completely the disparate head ends for purposes of risk mitigation. So we'll still maintain a very, very light, consider it a DOS-based BMS or lighting control system in a silo on-prem. In the case that we lose connectivity to the cloud and lose the platform, we can still run the building without having to go to the controller level. But yeah, no, Sabine is right. Those are individual platforms that feed into the data layer that either has then another application layer that amalgamates for command and control and visualization, or it's inherent to the data layer in our case.
Yeah, I'll add to that really quickly. There's just capabilities that our sort of siloed systems don't have, right? So we've been talking a lot about data modeling. We've been talking a lot about an API. We've been talking a lot about the ability to administer data connections and manage that. And just the on-site legacy systems weren't built to do really any of those things. Okay, so this one's from Andrew talking about building your own IDL. So he's asking who supports the software and infrastructure stack? Is it the IT organization, or does the facilities/energy team build the internal resources for this?
The way that I've seen it done in the past is that you have the tech team internal to the company that'll do this, or you can hire a third party to come in and do this. Like I've stood these up myself. The software itself, like the infrastructure, or I should say the software, like for example, if you do it with Bigtable, which is a Google product, or you do it with SQL, right? Like the SQL infrastructure, that software is maintained obviously by Microsoft or by Google, so it's fine. The infrastructure can be typically owned by your technology team or by your IT group. That's what we like to see, is that like your IT group owns all that infrastructure, but the users are those super users in the system that are capable of dealing with it. So you have to have technologists that are involved in this whole thing, and it has to include your IT group. We prefer those to be managed internally, and by we I mean like my company, but others like with Sabine's group, they've got a dedicated group of SWEs that are doing both the networking side, that are doing the independent data layer side, and they're all internal to Google.
Yeah, I was just going to add that's a really good question, because facility operation has some ownership around getting that data and the cybersecurity aspect of it, but they are OT experts, and then IoT kind of is a bridge between the two. So we have a group that's very IT specific, a group that's very OT specific. The way we're kind of thinking of it right now is all the way to BACnet Modbus, and serial connection is OT world. Facility operation owns it. Once it touches the gateway and starts connecting to cloud, so the network and the cloud connectivity becomes the IoT kind of more IT trained team. But really they have to work hand in hand.
Love it. All right, we'll keep going here. This is a good question from Daniel, and I'm going to hit all these. So if I haven't prioritized your question yet, we'll get there. I'm trying to string them together in ways that make sense. Daniel's asking a question that I feel like a lot of people ask about data layers, is that what use cases justify going from buying a point solution to jumping to having a separate layer of the infrastructure be the data layer? I think a lot of people say, well, if I'm just going to do, like Sabine, you mentioned meter reporting. Like, why wouldn't I just buy a meter reporting application and then just call it a day? What justifies going beyond a point solution?
The answer is the inevitable second use case. It's going to happen. As soon as you have the one use case, you're going to get another one, right? The availability of that data is going to enable other things.
Even the first use case, I feel, Trevor, like this, if you have scale, just getting meter data from different buildings that have different meter installed, different energy management system, you can't. It's really hard to have one vendor to pick. So I think the scale is what defines the decision. Can you go with one vendor across your entire portfolio across the world? Meter would be the easiest case. If you can do it, that's great. I think scale for us was a problem, and then certainly then the second use case that has integration of systems. Now you can't.
Yeah, I always like to talk about all the things you can do with meter data. You can enable so many different applications. And then you move on to HVAC. You can enable so many different applications with HVAC data. Are you trying to show dashboards? Are you trying to do FTD? Are you trying to enable supervisory control? Are you trying to enable occupant control of their set point? Like, there are so many different things you can do with the same data. And so just thinking about all the redundant integrations makes people's Heads explode. Okay, this one's off the wall a little bit. Open ADR. So for those people that don't know what that is, we're basically talking about integrating with the utility in some way, standardizing that communication. Where does that fit into this equation? I think this audience comes from a lot of that utility world. So at what point do we connect either an application with the utility grid, or does it go at the data layer? Trevor, maybe you have some knowledge from some of your customers that are doing this.
Oh, it definitely happens at the data layer. But I guess what is the particular question? Like, just where does
it's a very broad question. How does it fit in?
I mean, it's an application like any other application, right? Except it's bidirectional connectivity. So like, assuming that the organizational pieces are there, like that you like a big company is willing to like accept those demand response event requests, right? And like just let it do its thing. It literally the data layer, you have one API talking to another API, this thing's sending us a request, this system acknowledges that request, magic happens, the system postures, and then boom, you get the request back saying mission accomplished. And then you use that API that you sent the original request to request things like KW data to see the impact of what you're doing. It's very future. I think, we have got a little ways to go before we see it really effective in practice at scale, but it's a really good idea.
Yeah, it feels to me like a question just like the data layer itself. Like you could have an application connect to the grid, yes. But as soon as you get to more than one use case, you might as well bring that in at the infrastructure layer. Okay, we good on that one. Let's talk about outages. So somebody mentioned, Thano, I think you mentioned losing the connection to the cloud. Can we talk about how you guys think about setting up this infrastructure to sort of provide resilience for your stack?
Yeah, I mean, like as I mentioned, you want to fall back, especially when you're operating an asset, and it'll be less and less relevant as we continue to centralize and hopefully have less and less people on the site that are technically inclined as they're operating more remotely through a centralized command center, which is what we're actually building in Vancouver as we speak, as our first one, where we're going to control the entire portfolio there and then expand it across. But it's really, again, connectivity layer, ensuring that you have robust and redundant connectivity, and then resiliency at the cloud level. And if you have those things, they'll, and start putting into contracts that you require, at least 2 nines, right? Maybe more, maybe 1, depending on how critical the operation is that you're running. That's kind of how we look at it. So it's a tiered approach to risk management when it comes to outages.
Yeah, I agree that I don't think there's one solution fits all. Like Thano mentioned earlier, you had the BMS at end for the local technician, but also you have not all use cases need real-time access to the data. So cloud is a good place for large analytics and historical data. It's actually quite fast as well, but you can have edge device and on-prem. There's all three are opportunities that solves different use cases.
All right. Someone's asking, basically this all sounds expensive for people with large buildings and deep pockets and data scientists and programmers. Are there affordable solutions for smaller organizations? Anybody want to jump in there?
Yeah, so that's why you go to the application combined with the data layer, right? Like that is the most scale, or a solution that is probably the most cost effective when you're looking at certain sizes of portfolios that already have value-driven applications built in natively, so that you can justify the spend, right? And then even then, what may happen, and we're doing it to an extent too, as I mentioned, we're building our own enterprise data platform. And when I say building our own, it's like we're not coding we're taking a number of tools and assembling them so to build that layer that will ingest code data where it makes sense. So, I think there's an element that we haven't really talked about too, which could look like a bit of a hybrid, where you have a data layer that does a lot of things for the building that have applications built in, but you still have a separate one where you pull data out that you feel is appropriate to pull out, so that you can spin up various different visualizations or analytics or things separately. So, we talked about the three options. The one thing that I don't think we did say is there is an opportunity to have an independent layer and one with applications built in, depending on what your use cases are. So anyway, a bit of an aside, but as when you're smaller, it's unfortunate, but you have to look at more and more turnkey solutions. Even though that, as Trevor alluded to earlier, it puts you in a bit of a position where you're kind of stuck with what you have. But when dollars are what they are, then you buy what you can buy and you get the best out of it that you can.
One alternative take to that, because I don't disagree, like you can go out and get very cost-effective applications that, get you what you need, justify their value. But cloud infrastructure today is not that hard to use. And it's also not that expensive. And so like if somebody's like hell-bent to do this and they're kind of on that DIY path, 100% encourage that. There are a lot of things that you can gain with just a little bit of data. And even if it's clunky, it still can work. I've seen it happen and I've done it myself. I highly encourage it.
I think there's a good point to make here where the IDL that we're discussing right now is really about dynamic telemetry data. And that's what it is. It doesn't host every data you need for the operation of your building. And so this, we call it the RUSE data platform in our case, this other data layer that has a set of more static information of representation of your building, number of tickets, number, size, number of people that should be in there is a separate entity and they have to communicate together. So there's even more complexity to what we're describing, right? IDL is a set of information in cloud. And then there's other cloud interface or other data layer of sorts that host different type of information. And then somehow they connect, and that's where you do your dashboard representation or other things that tell a really complete story.
Yeah, I would just add there are a number of, so we've done some research around smaller buildings, like under 50,000 square feet, like very small buildings. And the biggest thing for them to worry about is actually getting digital devices at all, right? So don't worry about that until you have at least the ability to start turning your equipment on and off and doing other sequences that are just standard in larger buildings.
I'll just on that point, like our portfolio, as large as it is, has a number of old residential buildings that don't have building automation systems, that don't have any system. So data layer for what? So there's a lot of retrofit work that needs to be done before you even have this conversation.
All right. Can we answer this in a minute? Someone answer this, but let's keep it very quick. Very quick. What do new IoT protocols change about this discussion, like Matter, for example? Will it be easier to extract data? Is it easier to extract data when those standards are in place?
I'm not familiar with Matter, so I can't speak to it specifically, but I think it depends on what kind of standard you're talking about. Is this like a like MQTT, where it's like a communication protocol? Is it a semantic standard? Either way, our industry desperately needs standardization. We have it in a lot of cases at the protocol level, right? And the MQTT to cloud piece is I don't know, I see that as being the most viable and honestly the most adopted option. I'm seeing BMS manufacturers now coming out with MQTT to cloud options, right? But that semantic bit is still just, oh my God, it's such garbage. Even with all the work that's been done around it, it's because there's just a huge, diversity of equipment and things that you can model. And the model is dictated by opinion, or like an opinionation about what you need or care about.
All right.
So yes, new standards are always good. You can learn something.
Standards are good. That's great. All right. Thank you to you three. And thank you to our 100 plus people in the audience that hung around for this nerdy discussion.
James, I just want to thank you and the panel on behalf of the Smart Building Center and this conference for a really great conversation. We really appreciate it. To our audience, we're going to take a break now, go back to the WebEx agenda to see your session options beginning in about an hour. Thanks so much, everyone.
All right. Thanks, Stan.
You're welcome.
See you, everyone.